Okay. Okay, welcome. So I'm here for another daily code challenge. I just snuck in, 6 minutes before the end of the day, so Monday will be taken care of here. I'm actually on site with a customer, and so I've got Mr. Eric Peterson next to me here.
Howdy, folks.
So we're going to work on this little code kata for today. There are more and more CFML ones being added all the time, so we're going to grab another one. Brad Wood's been hard at work trying to get us some tougher ones, but I don't really want to spend 3 or 4 hours on here live stream with you guys just to get a couple of these done, so we'll just jump and do an easy one. So this one's a Scrabble score, so basically we have to roll through an array or a string and figure out how many points we'd get if we were playing Scrabble. So let's jump in here. I'm going to shrink it down a little bit so we can at least fit some stuff in here. Okay, so we have to write a program that, given a word, computes the Scrabble score for that word. And the letter values you see here, certain letters have 1s, a couple of us have 2s, 3s, 4s, 5, 8, 10. So we have a dictionary basically that's set up here. So we've got variables $dict, and then we have all the values, and then we have our Scrabble scores here.
Quite handy of them to give us that dictionary.
Yeah, I know. A couple of the other ones I was doing, I almost made my own little dictionary, but I decided to try and do it a little trickier. So I used character, like the ASCII character codes and stuff like that, and regex, etc. This one should be pretty easy. So, okay. So Eric, how would you go about doing this?
I'm a big fan of the functional style, and when I hear score, add, I'm going to think somehow make this an array and reduce it.
Okay, so we're going to do no variables, just return something straight, I assume?
It's the best kind of function. No temporary variables.
Okay, so how will we start this one? So first we got a string, we got to turn it into an array, right? So
we should be able to call list to array. Fun note, since we are in Lucy, list to array is both a built-in function and a member function. So you can call this straight off of string if you'd like.
So we do string.list to array.
Yep. And the delimiter here will be the empty string to make sure we split to every letter.
Okay. And it's obviously going to return our array so then we can chain, right?
Right.
So then what do we want to do?
Well, here we'll have an array of every letter, and we want to translate those letters into numbers. So when you want to take one of every array and transform it, that's a map. So we're going to map here.
Okay. So then inside our map takes a closure, right?
Mm-hmm.
So what are we going to do inside of that?
Well, we'll get a character inside each. And I think we can just return the lookup value in the hash in the dictionary above.
Okay, so variables $dict, and then we're going to use the array notation and pass in the character, which is the key. So if we get a letter, that should work, and since we're not case sensitive, it shouldn't be a problem, right? So
yeah, we could be super defensive and return something like 0 if it's not in the dictionary, but it probably won't matter for this kata.
actually, they said there are empty strings and spaces that could show up.
Oh, look at that! Empty string should return 0. And it can contain
fine.
White spaces.
Yeah.
So, yeah.
So
let's put in that like a key exists check on that dictionary.
Okay, so we'll do variables. Actually, so struct key exists. Variables dot $dict. So that's our struct that we're checking for, and then the name of the key will be the character.
Right.
So, running out of space on this. Let me shrink it down one more little click here, just while we're working, and we'll blow it back up in a minute. Okay, so now we can do.
So if it exists, we'll return the lookup like you have. And otherwise, I think we're going to want to return 0 because that will skip it.
Yeah, so struct exists, and that should probably be in quotes, parentheses, and then return that if it exists, otherwise we return 0. So that will give us back. So the first line here, we take our string, we make an array. So we have an array of characters, and then after this map we're going to have an array again, but the array, instead of having the characters, will actually have the points that each character would score, and then we need to go and take that and get the sum of all the points, right?
Right.
So when you're doing sums in functional programming,
you're looking at a reduce because you're taking an array of items and you're coming up with one value.
So here we have a sum and we have the new value.
Right, and those both go into a function.
That's right. I'm sorry. There's other things you can get as well. I think you can actually get the index, which is the what counter you are basically inside of the array, and you can also get the entire array as well.
Right.
But we don't need that right now, so we don't include those. Okay.
One other parameter you'll want to reduce is the initial value. So in this case, with the sum, we're going to start with 0.
Yep. And so there's two inputs. One is the function, and the second one is the 0 on the reduce function itself.
Yeah, it's the starting value for that first function argument.
Yep.
We're calling it sum. You can call it anything you want.
So I'll format it out a little bit so it's more readable. Okay, so inside this function, what are we going to do with that?
Well, you got to make sure you return something, otherwise you'll get a weird error. And in this case, we just want to return whatever the sum is plus the new value.
Okay, and they should all be numbers because we either got a character transformed into the number here, or a 0 in those odd cases that we have nothing. So we shouldn't have a problem with this.
Yeah, I think we run our sample tests and see what we get.
Yep. So we have a string coming in. String gets converted to an array of characters. Then we convert that to the map converts it to an array of numbers, and then reduce takes those numbers, adds them all up, and gives us the total sum, and we are returning that. So, unless I have some issues,
let's see those sample tests run.
let me look to see what they have here. So they have a 0 for an empty string, 1 for an A, 6 for a street. So we've got several little tests here. So let's run these here. So, yeah, several little ones. I've got some white spaces here with the street with spaces. So it's a good little sample set. Sometimes the test can be pretty easy. This doesn't look too bad.
Nice.
Wow, first time.
So now, what I love to do in Tester Green is go...
refactor.
Maybe, do some refactoring. So the first thing I think I'd do, not saying this is necessarily better, but we're doing that struct key exists check. What we could do here is filter out anything that's not in that dictionary. So I'm going to use an arrow function because I'm fun like that. And I'm going to say I only want to keep stuff where it exists in that dictionary. And now we can come down below. We can get rid of that entire check because those will just not exist anymore. So let's run those sample tests, see if our change broke anything. And we're still passing.
Cool. So let's go more functional here as well. So let's use arrows function for the next one.
Yeah, I love. My favorite thing about arrow functions is you can get rid of that return when you don't use braces on it.
Yep. So now, in this one, we got a function that we're passing character into, and we are returning this. That's what the arrow function does.
Yeah. Let's just make sure to run our tests. It's nice to run your tests often when refactoring, just so you can pinpoint where you made the mistake. I've often made, 6, 10 changes at once, and then I'm like, oh, I'm not exactly sure where that change happened. So here, let's shorten things even more there. Now we're playing code golf.
Okay, so then the next one on the list, assuming they all pass, they do, we have the reduce.
Yeah, we could even make this an arrow function.
Yep.
Good old Lucy 5 and their arrow functions. And Cold Fusion 2018.
Yeah, so because we're returning this, that's all we need is just the value that we're actually returning. We'll see if we need parentheses around these two. Because we're adding it's a simple function, it shouldn't need it, but you never know.
Yeah.
But because we're actually doing a comma and then the 0, I'll be curious to see if there's any issues.
Yeah, me too.
Sometimes you need to be a little more careful. Let's be a rebel and just try and run like this. Yeah. Okay, let's run the test.
Yeah. There you go.
I didn't break anything.
Woohoo! I think my only question would be to see. I do believe you need a 0 there, so I take that back. There is the case where this becomes the first value in the. If you don't pass the second argument, the first value becomes that accumulator. But I don't
think it works in Cold Fusion though.
Yeah.
So let's run it and we'll see some failing tests just to prove that we're not just faking it here.
I mean, we are faking it, but not in that way. Yep.
Yeah. See. So
Alright,
no.
so Cold Fusion does not take the first value of an array as the initial value. You must provide an initial value.
Yeah, but Brad was talking to me because obviously he's doing a lot of katas lately. He was saying how you can actually use a sample value. So you could actually pass in, name parameters, and that would work.
I know
Sorry.
one thing I've done when I really do want to just use the first value is just inside the loop, check if that accumulator is null, and if it is, set it to the first value. But
yeah.
So, anything else you'd want to change on this?
No, I mean, obviously we can make our variable name shorter if we're really trying to play code golf, but we don't need to.
Oh, no, let's do it. Sum and value. Look at how short this is.
Well, if you want to make it shorter, we could really get rid of our scopes and remove variables, but although we do like to scope our variables for speed and performance, but this is code golf, so we can get rid of that too. And to be honest, we could even come up here and rename our dictionary.
Oh man, now we're really getting down there.
Yeah, we could get rid of that and just make it $D or just $, or just D. But we'll just leave the $sign in there just because.
So if you're looking at this point, you're probably thinking, well, it used to kind of make sense, and now I have no idea. But that's the great thing that having, a suite of tests backing up your function gives you. We can play around with this, see that, maybe we went, a couple steps too far. We'll back that out. Even that sum and new value made sense. If I was doing it, I think I'd leave it here. C makes sense as character for me. Yeah. It might not for you. You might want char.
Yeah.
Whatever you and your team decide on.
Yeah, a lot of times, a lot of those types of names, they might be reserved words too, so you just got to be careful. That's why a lot of times I'll either use something short or extra long just so I don't clash. I don't think it's an issue with chars, but that might be something. I know, I like to have. We ran into that. You ran into that the other day with query, didn't you?
Oh yes, query, my friends, is a reserved word in Lucy for their query script syntax. So be wary when naming your variables query. For the most part, it handles it fine. It probably will just look really weird in formatting in your IDE. So,
yeah. So,
should we do the attempt? Submit this?
We'll see what else everybody else is doing and how they're doing it.
See if we pass our random tests that are generated.
I think we broke it down pretty well. We got distinct steps, lots of logic.
Aha!
19 passed, 0 failed. Wow. There's a random test in there where they just throw a bunch of different characters in and see what shows up.
I like how they're uppercase letters and some are lowercase for the languages where that matters. Obviously, with Cold Fusion, it's case insensitive, so it didn't matter for us. Yeah,
unless we choose to use the certain functions.
Right, we could use compare if it really mattered to be case sensitive.
Yeah, we could do find no case for insensitive if we were looking for finding and stuff like that. But okay, so
alrighty.
Now let me just shrink this a bit. I think I can't see all the buttons. There we go.
I was gonna say, where's our submit button?
So we'll submit it, and then I'll blow it up here so we can see a little more.
Alrighty. Okay. So does this just show the Cold Fusion languages?
We know who this guy is.
We do. Oh, look at that Elvis operator. And I guess Lucy has an erase sum method? What? Fine, John. You win at Cold Golf.
So we'll say that's pretty clever.
It is clever. And I say pretty readable, too.
Yeah.
Hey, John here replaced our struct key exists with the Elvis operator. Be wary if you're using that in Adobe or especially cross-engine as they behave differently. And then it looks like there's an erase sum method. Do you want to look that up, Gavin, on CF Docs? I'm curious if that's only in Lucy.
And just so you know, too, if you typed sum in here, it'll bring up erase sums. If you do sum and push enter, you will get not found. So when you're typing, click. And so a lot of the member functions, they remove the type in front of it, so like .sum, but when you're searching, you need to erase sum.
Oh, look at this. There is a CF method for erase sum. So, I'll be.
There we go. We both learned something today. So that's where some of the solutions is pretty cool. Let's scroll down and see what else. Oh, that's me.
Gavin!
Really, it's Eric in disguise.
Nah, it's both of us. Okay, let's see what else we got.
We've got Dave.
Ooh, I want to
replace no case.
Using a regex to get rid of anything that's not a character.
Mm-hmm.
I am curious on this one. Oh, no case. Haha. I was curious about the regex, but we're replacing no case, so that makes sense.
Yep, and so most functions have a no case for a lot of the string functions for Cold Fusion. So be aware that by default they're no case.
Cool.
By default they are case sensitive, even though the language isn't.
So we're using a regex here where we use the filter, and it looks like they're using a each loop with a total variable on the outside where we used reduce.
Yep.
I like to play a game with my code where I don't have any, like, I'm going to go back up here, any vars.
Yeah.
So there's nothing wrong with this, but whenever I see this, I think, I wonder if there's a way to not have those.
Yeah, and that's one of the things that I've learned with design patterns over the years and everything. There's a lot of things like those functional tools are being brought out. Like, hey, a lot of times we set a variable, we loop over something, adding something to it, and then we return it at the end. Guess what? We do that all the time. Let's make that a reduce. And there's certain things like that. That's where maps and filters, because everyone uses them day after day after day. You build them and write them and over again. So they said, let's just make a language feature that does that.
Yeah, it's nice to have a common term to describe what you're doing, right?
Yeah.
When I see a map, I know I'm getting an array back. When I see a filter, I know it's going to have the same or less.
Yep. So it's an array with just a few things filtered in or out.
Cool. Let's see. Adrian Sanchez. What did you do? List to array, reduce, Look, the find no case inline here.
Yep. But
and doing the looking up in the dictionary or zero.
Yep. Nice.
That's kind of a combination between ours and John's.
Yep. Pretty cool.
Let's see.
I don't know who Deca is.
Oh, this is interesting. He's mapping over and setting the total inside. So this is probably, you don't really need maps since we're setting the variable outside, but
you probably do it each or something.
Yeah.
Do the same type of logic, but
okay.
But yeah, I mean, still you're going through the entire array and then processing each item one by one
and checking for the key to exist.
Yeah, and then doing something with it and just passing that total out.
Let's see. Good old for loop.
Yep. Well, this is the new for loop. We got the var item in something compared to
indexes.
Indexes with it, yeah.
Whew.
And man, the funny thing is, doing all these katas, you have to do the JavaScript version or another language before you can translate them to ColdFusion. So it's been fun listening to Brad complain about how terrible JavaScript is. Like when you're looping through, a JavaScript for item in an array. For one, you're not supposed to do that because it won't guarantee the order, apparently in JavaScript. And you get back the index by default, not the item. If you want to, you can pass in parentheses and get index, comma, item. But usually you get back the index. And they're all zero arrays, zero-based arrays. And there's a few other things. But yeah, so apparently in JavaScript, you don't do for item and array because it says it's not consistent, it's not reliable, and you shouldn't do it. So Brad found out the hard way about that. So another reason for him not to like JavaScript and Node.
Yeah, not like he didn't have enough. So I'm curious, Gavin, if you know, I don't personally use strings as lists. If I said var character in and I pasted a string, do you know if it would give me each character? Or would it just be a syntax error?
I think it depends on what engine you're running it in. Yeah, by default, I don't know. I know that some of the member functions work on strings as lists in Lucy. ColdFusion they don't, but some do. There's a weird subset, and so I always use list to array to make sure I'm dealing with an array because I know that works.
Anybody who's done any code reviews with me knows that I refuse to let them commit lists. I think if you have something that really is a list, make it an array.
Yep. And another reason for this, which I told Eric, and he was like, that's a good point, is that in ColdFusion, strings are immutable objects. So if you're actually doing string concatenation, every single time you concatenate, you're actually creating a new variable with that new concatenated string. So if you're doing adding 1,000 things to an array or adding 1,000 things into a string list, the array blows it away because you're basically creating 1,000 variables with the list, and array you're just adding an item to an existing variable. So, anyways,
let's see what we got here. Somebody's doing an uppercase check here, which isn't strictly needed, but it's nice to be consistent with your data.
Yep.
No var.
Ooh.
Don't call this twice in a row on different threads.
Oh, here's Brad, man. Oh, look. Oh,
why did he put it? He organized it. That's interesting.
Well, I think, did he actually do this?
List solution? Each, Brad. I don't care if it's shorter.
Oh, so he just actually put it inside the Scrabble store. And
look at this little thing. Can you say code golf? He didn't even put spaces. All right, Brad. All right. That looks almost identical to John's, right?
Yeah, and this is Stefan 153. He's got hundreds of languages under his belt. I think he's one of the main admins in the area. He's probably one of the people that converted it over. So
I've seen this name before.
Jason Steinhauser, I think it is. We mentioned him on the podcast last week.
And looks pretty similar to the one before. So
pretty nice.
Nice works.
So again, simple little thing, little task, but have a little fun with it and practice your functional programming. That's what I use it for, because I got to work on my functional programming. But yeah, it just helps to get comfortable with it, and yeah, so I'm having fun with it. What about you, Eric? What's your honor?
Oh, I'm somewhere. Yeah, I'm somewhere at the like 450 level. I did a lot of JavaScript ones back at some meetups. So when I was learning, it's kind of nice. JavaScript translates to CFML pretty easily. So especially all the functional stuff.
Yeah, and that's what I used it for as well. Like I said, that's my weakness. I admit, I'm a six tagger in disguise. So
when they pass, doesn't matter.
Yeah.
Cool.
So, cool. Well, thanks, Eric, for helping me get through this. And we're hanging out most of this week working on a client, so I might pull them in here. Maybe we'll try a little harder one. So, I don't know. Anyways, you guys have a good one, and we'll catch you later.
See ya.
Bye.